everyone! Today we have a very special triangle. One side is sine x, the other is sine 2x, and the hypotenuse is sine 3x. We are asked to find the possible values of x. The moment you see this triangle, I'm sure the Pythagorean theorem comes to your mind as well. Yes, this should be the most suitable solution. There's no point in making things more complicated. Let's give it a try. So we write sine squared x plus sine squared 2x equals sine squared 3x. Here, we will use the half-angle formulas. Sine squared alpha equals 1 minus cosine 2 alpha over 2. We already proved the trigonometric half-angle formulas earlier on this channel. Those who are curious can find the link at the top right. Okay, now let's write everything in place. For sine squared x, we put this. For sine squared 2x, we put this. And for sine squared 3x, we put this as well. As you can see, they all have denominator 2, so let's cancel those and simplify the equation a little. Good, let's keep this aside for now. But to move forward, we need to use some other identities. Let's recall two different formulas. For example, what was the cosine addition formula? Cosine A plus cosine B equals 2 times cosine of half of the sum of the two angles times cosine of half of the difference of the two angles. This is a very important theorem. Unfortunately, we haven't yet proved it on the channel. Maybe one day we can explain it if you want. It's up to you, feel free to write in the comments. That was the first formula. Our second important one comes from the half-angle formulas. Cosine 2 alpha equals 2 times cosine squared alpha minus 1. We already proved this one. Now, what are these formulas good for? In our main equation above, we will use the cosine addition formula here and the half-angle formula here. So cosine 4x plus cosine 2x actually becomes 2 times cosine 3x times cosine x. And cosine 6x becomes 2 times cosine squared 3x minus 1. Let's substitute them back in. On the right side, let's expand the parentheses. Both sides have a 2, so we cancel them. Then we move the right-hand side to the left and set the equation equal to 0. Now we notice that both sides have cosine 3x, so let's factor out cosine 3x. Great, now we have a nice equation. When does this equation equal to 0? Either cosine 3x equals 0. In this case, 3x equals pi over 2. And the period of cosine being 0 is pi, that is 180 degrees, right? So we write pi over 2 plus k pi. To find x, we divide both sides by 3. Nice, let's keep this aside. The second option is that cosine 3x equals cosine x. In this case, we have two possibilities. Either 3x equals x, and don't forget to add 2n pi, because the period of cosine is 2 pi, which means every 360 degrees, it repeats the same value. Don't confuse this with the pi period we mentioned earlier, because that was for cosine being 0. They are different. Or 3x equals negative x plus 2n pi. Why? Because cosine is an even function. Cosine of x equals cosine of negative x. Now, if you do the necessary algebra to solve for x, you find that x equals n pi over 2. Okay, we've written a lot so far. But one very important point remains. Pay attention. These lengths, sine x, sine 2x, sine 3x, are the sides of a triangle. Since lengths cannot be 0 or negative, we must say this. For sine x greater than 0, angle x must be between 0 and pi. For sine 2x greater than 0, x must be between 0 and pi over 2. And for sine 3x greater than 0, x must be between 0 and pi over 3. All three of these conditions are satisfied only in this common interval, right? But remember, we also had restrictions from earlier. For example, in the case where we checked if cosine 3x equals cosine x, we said that x must be multiples of pi over 2. But even if n equals 0 or 1, that makes x equal to 0 or pi over 2, which contradicts the last condition. So we get nothing useful from here. Looking at the earlier equation with k as an integer, if we take k equals 0, then x equals pi over 6. And this perfectly satisfies the last condition. Therefore, the correct, and interestingly the only valid solution is x equals pi over 6, which is actually 30 degrees. Yes, we went through many steps. I hope it was clear. See you in the next lesson.